or that's going to be due on Wednesday, you know, and today's Tuesday. That's not fair either. So I'll always, you know, give you about a week from the date that I find out that there wasn't a due date. But it would have been nice to know that in advance. And I'm sure that some of y'all noticed in advance, you know, like last week or something, it didn't have a due week. So we're going to have a bounty, a reward. The first person to text me to let me know of problems like homework has no due date, video not uploaded, or link doesn't work, or some folder has no submission button. Right. Any of those problems, any problems like that, the first person to text me about it gets 1% on the midterm, or on the final if we're past the midterm, right? So you find 5 problems with the class, you get 5%, right? That's half a letter grade on your midterm. So hopefully I don't persuade you, right? No reason to wait until the day, you know, that it's due to let me know. And if 2 people tell me before I fix it, then you'll both get credit for it, right? That makes sense? So anyways, homework 2 is due in about a week or something like that. Let's go take a look at when we actually assigned it.
I think you assigned it on Thursday.
September 8th. Is that really what I wanted? When is September 8th? Well, we're going to make it September 9th, so to do a week from now.
And I think I already got that one done.
That's cool. Yeah, it wasn't that hard, and I bet most of you got it done. But when there's not a due date, I'm not going to punish you for not doing it, right? Because it doesn't show up at the top of your list if there's no due date attached to it. So I always want to make sure it's got one.
At least I got it. About you.
Yeah, thank you for letting me know. See, you get your bonus. You were the first one to let me know. And then you were the second one, so I should give it to you too. All right, let's go ahead and take roll, and then we'll be into the class.
I think I'm much.
So back to where we were. Well, we had to have been done with chapter 1, were we not? Maybe we're not.
We've been through chapter 1. Your whole book is from Pearson. Wait a minute, you got that stuff from Pearson?
Yeah.
Oh, wow. My last programming class, ours was Cengage, which absolutely...
It's not my favorite thing, but all right.
It's not good. Heck, my teacher didn't like it too much. And unfortunately, me too. They actually got a Python clone.
Yeah. So we got various components of our program. Our programs are made up of keywords, as I mentioned. Those are the special words that we're not allowed to use for just whatever purposes we want. They actually make up the language. If, while, using, namespace, for, right? All of those things are keywords. And then the programmer-defined identifiers. Those are the variable names and the function names. Now, there are specific rules that our identifiers have to follow. And then there are recommendations as well. But the rules for identifiers, which are names, like variable names and function names. They can be letters, they can be digits, they can be underscores, and in some languages, in some platforms, $sign is actually a valid identifier. Visual Studio supports that, but it's non-standard, so we're not going to use $signs. And as a matter of fact, the textbook, I believe, just flat out says $signs will not work, but oddly enough, they will. So we're going to erase that $sign. These are the 3 things that a variable name can be made of. Any mixture of those, right? You feel like making a variable name that looks like that? How about that? Yeah, okay. Anyways, that's silly, but it's a valid variable name. There's only one little subclause of that, which is that it cannot begin with a digit. So tax rate 2019 is valid. 2019 tax rate is not valid. That's not a valid variable name, just because it starts with a digit. Same rules as Python, so if you've taken Python, then you're familiar with that. Now, some programmers like to do what's known as camel case. Camel case is when you have capital letters in the middle of your variable names to denote additional words. So caps in the middle, like this. You know, patient height, right? There's a cap there, right? First name, there's a capital there.
Is there a particular reason why some coders prefer camel case? Like, why? What was the logic behind? Hey, let's.
Yeah.
We'll just capitalize the second and third.
Right. Why is a good question, and the only answer I'll give you is that the people who invent the language tend to set the tone that other people follow. And so in the 70s, underscores were popular, and people did not use camel case. And then somebody decided that camel case was easier to read than underscores. I don't know who made that decision. And so languages like Java and C# started following that. But even in those languages, C# doesn't recommend using a lowercase first letter. They use an uppercase first letter in certain cases. So it's just whoever made up the programming manual that was first adopted kind of sets the tone for the developers who come after that.
There's some logic behind it, or if it was just, we're going to do it this way.
There's no real logic to it. You get to pick which one you want. So camel case is a popular way of doing it. Also, somebody came up with the absolutely absurd name of snake case, which is when you use underscores, right? I'm not going to call it that, but underscores is another way. First underscore name. Now, there's really no reason to mix those. That'd be pretty silly. I think if we're looking for a really good reason for some people to have used underscores, back in the 60s, there were languages where if you type things in uppercase, then they were programming commands. And if you type things in lowercase, they were variable names, or vice versa, so you would never mix them. And then once people invented the idea of variable names that could be upper and lowercase, why not use them? I don't care which you use. I don't even care if you mix them up, and use, half your variable names. The only thing that I will note is that in class, if I start making variable names that have uppercase letters in the middle of them, then when I'm wandering around helping people fix typos, half the problems are going to be because people capitalized it someplace and then they didn't capitalize it somewhere else. Right. So if I was typing first name equals, and if first name is this or whatever, then I guarantee that somebody's going to have something that looks like this, and it's going to be a syntax error. And we'll have to figure out that it's because they didn't capitalize the N. So honestly, I do not use camel case much in my teaching, even though it is now the most popular style. Most popular style because Java enforces it. Well, they don't enforce it, but all their code examples and all their own code has it. And C# uses that now. All their code examples and internal documentation and stuff like that do that. So, but you'll see me use underscores just because it's a lot clearer to type in first underscore name, and then I don't have to worry that sometimes we're going to capitalize the N and sometimes not. And then we have the operators. The operators are the symbols. Plus, minus, multiplication, division. There are different categories of operators. There's the vast majority of them are what are known as binary operators. Not binary because it's zeros and ones, but binary meaning 2. So we have operators, which are the symbols like equals and equals and plus and minus and addition and right, and so all that stuff. Yep, all of those. I mean, we could go nuts. There we go, right? Those are all operators. Talking about them in turn, that's the assignment operator. Example, x equals 3. That is the equality operator, or the comparison operator. If x equals 3. You can't mix them up. The compiler may not catch it if you do. What do I mean you can't mix them up? What if I did this? X equals 4. If parentheses x equals 0. But what if I forgot and only used one?
You're gonna get an error.
You would
I don't
think.
understand
You would
why-
think the compiler in Java or C# or Python would flag that as an error, a syntax error, and it would not compile. In C++, it'll give you a warning maybe, but it'll still make an executable, and when it runs, what happens is x gets erased and replaced by 0. You don't want the value of x to get replaced inside your if statement. If you had this code right here, I mean, we could even try it out. We could open up, if you didn't believe me, we could make it. This would print out yes, and the value of x, no matter what it was, would have been replaced by the value of 1. So you don't want to mix them up. You always want to use the equality operator if it's inside of an if or a while. So equality operator you use inside if and while statements. And then we have our arithmetic operators. Arithmetic operators, addition, subtraction, multiplication, division, modulus. And I wish this language had ** to mean to the power of, but it doesn't. I also wish it had that to mean to the power of, but it doesn't. It just flat out doesn't have an exponent operator. Neither does Java. I wish that they did. Why is Python the only one with an exponent operator? I don't know. You have to use a POW function to take something to the power of. And then you have the comparison operators, or the relational operators. EE is one of those, right? But you also have less than, greater than, less than or equal to, greater than, equal to. Wait, less than or equal to, greater than or equal to, and then not equal to. Then there are some other operators, logical operators, and, or, and not.
And there's the double, greater than, less than signs.
Yep, those are the stream operators. Like that, sending something to the screen or getting some input. Most of these are binary operators, meaning that they take two things. I'm not sure I listed, no, I've listed one thing that's not a binary operator, and it's that one. So there are unary operators, meaning they take only one piece of data. -3. X equals -3. Believe it or not, that minus sign, even though it's part of the number, is technically an operator. And it's the unary negation operator, meaning that it takes the data that follows it and switches it to be negative. Now our brain doesn't work like that. We just think that -3, that the minus is part of the number. But no, the number is 3. And then the minus sign is the unary negation operator that makes it negative. We almost never care about the fact that that's a unary operator. We just think of it as part of the number, right? -3, that's its value. And then also the exclamation mark, meaning not. Right? If you have not true, then that means false. Right? It takes the thing after it and it flips its truthiness, like Colbert used to say. Makes whatever used to be true false and vice versa. So those are the only unary operators that I'm aware of. We may find some more, but most are binary operators, meaning they take two pieces of data. They take two operands. Operands are the things on either side of the operator. If I do this, a equals 3. equal is the operator. A and 3 are the operands. Cout less than hello. Less than is the operator. Cout and hello are the operands. And so on. Less than and greater than, right? If x less than 3, less than is the operator. So what are the operands? X and 3.
What about if?
If is a keyword. Yep.
Wait a minute. Then why is Cout an operand?
Why is which one an operand?
Cout.
It's actually not a keyword. You'd think it is, but it's not. Let's go ahead and make a new project.
Hey.
Cout and CIN look like keywords, but they're not. They're kind of special case. Or they're not even that special, it's just that they get used so often that we think of them as being keywords.
I'm gonna grab my boilerplate.
Yep. Coming up soon. Boilerplate near you.
Except I'm gonna have to put at namespace. Include CMAF.
Oh. Yeah, I probably haven't changed that, have I? I need to put that in there.
I haven't changed mine yet.
Alrighty. View Solution Explorer. Right click on source files. Add new item. Lecture D. Paste. Alright. Notice what color all the keywords are. And notice what color Cout is.
It's black.
Cout is actually a variable. If we right click on it and say go to the declaration, oh well, I better show that functionality before I start showing it off. I'm going to make a variable called x. And then just for grins and giggles, I'm going to delete this later, but I'm going to insert like 20 blank lines, and then I'm going to say x is equal to 10.
20 blank lines.
Now here, if I highlight x, right, if I double click on x and do go to declaration, it blips me to where it was defined, right? I'm going to delete those blank lines now, they're silly, but I wanted you to see that go to declaration option. So now I'm going to go to Cout. Double click Cout, right click, and do go to declaration. And it took me inside a header file. So Cout really is a variable. It's a variable of type OStream. We certainly do not care about what OStream means right now and what iStream means and things like that. But Cout and CIN are not variables. Excuse me, they're not keywords, they are variables. And that was an incredibly good question. You're the first one who's ever asked that. I'm impressed. Now how do I get rid of this so that I don't have to
Mess with old.
Oh, here we go, here we go, here we go. I did not realize that it opened that in that little tab over there. That's strange. Get lost. Okay.
To be quite honest, that would probably be COBOL back in the 80s and 90s.
Yeah, COBOL goes back to the 50s. Invented by a woman named Grace Hopper and her team. And then we have the punctuation, you know, parentheses, curly braces, and semicolons.
I think the parentheses are usually for functions.
Yep, parentheses, enclose function parameters, and group parts of an expression if you need to. like x equals parentheses 3 minus y. And then you have those. The curly braces just declare blocks of code.
Excuse me.
Uh-huh.
Could I get a copy of the coding page? Because I don't have the includes and everything.
Okay, where you get those is if you go to modules and click on boilerplate.txt, it gets the whole thing.
Modules.
You ought to be able to copy and paste them.
Okay.
If when you copy and paste it, it puts it all in one line, like it does on me, then you might try actually opening the file, like this. Click on where it says download boilerplate, and then you can open that file. And then when you copy and paste it, it's not gonna be all on one line. Now, it was working great for them. It wasn't putting it on one line for them, but it does for me. Let me make sure you got it.
Yeah, because otherwise we typed it in every single time.
Yes.
Yeah, I did that, so go back. Or we could just hit Control-Z and undo it. Go back, double click on that, do the download thing. Go and open it. Yeah, then copy and paste.
So far.
And then we have this semicolon ends a statement. Now people want to get into the habit of putting that, I mean, you don't want to, but they think that they need to put that after every statement, including statements like this. This is wrong. If x equals 3, semicolon, see out, hello. That's totally wrong. Why? Because it's the same as if we had written this. That semicolon terminates the if statement. You don't want to terminate the if statement. You want to be able to execute the line of code that's underneath it. Right? Kind of like it was like that. If you had a semicolon there, no. So, you don't just put in semicolons everywhere, but you put them most places. I'll just make a generic rule that never put a semicolon on the line above an opening brace. If you follow that rule, you're pretty good. You're pretty well off. If we go back and we look at our code, not that there's a lot of code yet for us to look at, but if I put a semicolon here, it would have been in front of a curly brace, and that would not have been valid.
Like an unexpected curly brace?
Well, it just would not have compiled. If I put that semicolon there, then nope, not going to compile. So anytime you have a semicolon followed by on the next line a curly brace, the semicolon's at fault and it's not going to work.
This is going to ignore the process that you want to run.
Pardon me?
This is going to ignore the process and the curly braces that you want to run.
Yeah. It will do not what we want it to do, and its behavior will differ based on the keyword. If it's an if statement, it'll do the thing always. If it's a while loop, it'll just go into an infinite loop right then and there. So we don't want it to do that.
Infinite loop?
Yeah, let's do an infinite loop just for fun. Where'd my system pause go? I guess I deleted it. Not part of my boilerplate? I don't know. So here's what an infinite loop is. An infinite loop is just one that runs forever because what's known as the loop control variable never changes. Let's declare a variable like x, int x equals 1. And then we're going to say while parentheses x equals, or while x less than equal 10 in parentheses. Don't put a semicolon on the line, just like I lectured. On the next line, let's do a curly brace, see out, less than, quote, end the loop, comma, x equals space, end quote, less than x, less than E and DL. And now when you run it, it's just going to say in the loop x equals 1 a zillion times in a row until you end the program. And I forgot my system pause, so if you're on a PC and you deleted it like I did, system, parentheses, quote, pause, end quote, in parentheses,
It might
semicolon.
crash. I'm just kidding.
So here we go. Yeah. It's just going to do that forever. That's why it's called infinite loop. Now, yeah, you can stop it. Back in the olden days, like in the 60s or whatever, you might have to call a system administrator and get them to stop your program. Aren't we glad to have a little close box? Okay, so that's an infinite loop, and the reason we add an infinite loop is, what does a while do? It's like an if, except not only does it control going into the block, it controls when it can leave the block. And it can only leave the block when this condition is no longer true. But since x never changes, this condition is always true. If we don't want it to be an infinite loop, we have to modify the value of the loop control variable. So the next line of code inside my block, I think I will make x plus plus, semicolon. Now to count from 1 to 10. Like that. And what if I had mistakenly put a semicolon there?
It would not compile.
It'll compile, but it's not going to do what we want, which is nothing. It's inside an infinite loop that's doing absolutely nothing. It's as though we had written this. While x is less than or equal to 10, do nothing. And yeah, sure enough, that's what it does. So we never want to put a semicolon at the end of an if statement. We never want to do one after a while or a for. If you're ever in doubt about whether to put a semicolon there or not, leave it out, and then if it doesn't compile, put it. But it gets to be second nature very, very quickly. That you do it on everything except the flow control statements like if, for, while, and function declarations.
Let's do an infinite loop.
Want an infinite loop, you just comment out the x plus plus and it'll do it. Or put the semicolon there. And then the syntax are just the rules of the language. I know I've said this before, but in this particular language and in every other language I've used, the variable has to go on the left-hand side and the assigning value has to go on the right-hand side. And so if you tried to swap them, don't do this because it's going to be a failure. 10 is equal to x. That's good algebra, but it's not good code. The left-hand side always has to be the variable, and the right-hand side always has to be the expression that's going to get copied across the equal sign into the variable. So that's just a rule of syntax. Other rules of syntax is that every line, except for flow control statements like whiles and ifs and fors, ends with a semicolon. And that every function and every if and every while statement has parentheses after it. And inside there are arguments that control the behavior of the function or the ifs or the whiles.
Or the else's.
Else's don't have parentheses.
Oh, I'm surprised. CIT1173. Just kidding. And we're probably going to get into the hardcore stuff later in the semester.
So a variable is a named place in memory. Because we don't want to just store our salary in memory address 2,300,025 and then store our pay rate in memory address 2,003,026, right? You know, we don't want to have to declare an access memory like that. Instead, we'd rather say hours equals 30 and rate equals 12.5, like that. We would like to be able to give our things names, and that's why variables were created back someday in the 40s, before the invention of variables, people really didn't do that. They just assigned random numbers, or not random, right? But they had to actually address the particular byte in memory with a number, and they couldn't give it a name. So that's pretty primitive. I'm glad that we don't have to do that. So a variable, let's go ahead and add a comment.
That would make programming so much frustrating.
Yeah, so let's give ourselves a comment. A variable is a named place in memory, and it has 4 things. I may have already said this. A variable has a name, also known as an identifier, a type, a value, and an address. It's got all 4 of those things. So a variable has 4 attributes: a name, type, value, and address.
Variable has 4 attributes.
So for example, this x variable, its name is x, its type is, we'd have to scroll up to see how it was declared. Or I could do that right-click go to definition thing, and it would show me it's an int. Its value changes over time because it's not a constant, but when we started it, it was equal to 1. After it left the loop, it was equal to 11 because that was the value that let it escape that loop. And it has an address in memory. It sits in a certain byte. Now most programming languages don't let you see what the address is. It manages all that for you. C and C++ do let you find out what byte it is stored at. Let's just print that out, even though we're not going to use pointers for several more weeks. X, cout, less than quote, X is stored at memory address space, end quote, less than, ampersand X, less than, ENDL. That ampersand means address of. We're going to find out what the memory address of variable X is. Now let's declare another variable and get its address. So I'm going to make another variable, maybe Y, int space Y. I'm not going to even give it a value. Right now, all I care about is its address. And then I'm just going to copy this statement and paste it and change the X's to Y's.
That's probably why a lot of Tinker people use C++.
Well, pointers are very useful, but they're also very risky. And what do I mean by that? You can crash your program. You can make your program fail by writing to the wrong memory address. And in olden days, you could even crash the computer by doing that. Nowadays, operating systems try to prevent you from writing to memory addresses you don't own, so it'll only kill your own program, normally. Okay, so X is stored at this memory address, and then Y is stored at this memory address. Notice that it's in letters and numbers. That's hexadecimal. We haven't talked about that yet. But for some reason, the C++ developers decided that if you're printing out a pointer, it's going to print it in hexadecimal. So we're not going to talk about pointers again for a long time. At least probably a month or 2 before we get back to the idea of pointers. But the pointer is just a memory address. Java doesn't support them. C#, you're not supposed to use them. Python doesn't support them because using them has the inherent risk that if you use them incorrectly, it can crash. It can crash your program. So to create a variable, you have to give it a type. In Python, we were just able to say x equals 3. In this language, we have to also give it a type before we can use it. So you can't just turn around and say name equals, quote, Fred. end quote. We did not declare the variable, so that is a syntax error. It will not compile. We have to give it a type. Well, it better be string, right? String name equals Fred. So every variable has a name and a type and a value and an address. That means that every variable has to be declared before it can be used. Every variable must be declared, which means given a type, before it is used. Unlike some languages like Python. Once a variable is given a type, data compatible with that type is the only thing that can be stored in it. Once a variable is given a type, it can hold only data of that type. What do I mean by that? Well, y is an int. Int means whole numbers only. If I type in y is equal to 1.1, well, it's not a syntax error, but it's not going to magically change y in order to support holding a .1. It'll round y down. Y will equal 1 at that point, because y is not going to change to match the data type being assigned to it, unlike Python. That would work perfectly in Python. Once declared as an int, for this block of code, it's going to stay an int. So this doesn't work. Y is an int, so we'll just equal 1. Now, at least a float is kind of compatible with an int, right? Because they're both numbers. But if you try to do this, y equals, quote, Fred, end quote, semicolon, that's a flat-out syntax error. Because this is string data, and there's no way string data can be converted even into something closely approximating an int, right? They have nothing to do with each other. So this is just an error, flat-out error. Y is an int, so cannot hold string data.
Y equals Fred.
That also has other consequences. Sometimes you can do comparisons between data types that aren't the same. We might be able to do this if y equals 1.1. I wonder if it's going to count that as a syntax error. No. But y will never equal 1.1 because it's an integer. We defined it as an integer up here. This will never work because y is an integer. But let's see if it does. Wow, it worked? Question mark backslash n, end quote, semicolon. I wonder if it's going to work. Yeah, see, it did not print that. We might have expected it to because the line right above it says y equals 1.1. But what's happening is that y, since y is an int, it gets so-called truncated. All of the fractional data is lost, leaving only the whole number. So it gets rounded down to 1. And there's no way that 1 can equal 1.1. So it did not print, wow, it worked. Now what if we did this? This is going to be a flat-out error. So I'm just going to comment it out a minute. If y equals, quote, Fred, end quote. These are completely incompatible types, right? That's an integer, so we can't compare it against a string like that. Incompatible types.
I've gone through that before, and I didn't understand what was going on. And I was back in programming logic.
All right. Has anybody currently got like a syntax error or something on their screen they need me to come eyeball your screen? Just a second, I'll pause. So you can declare multiple variables on the same line as long as they're of the same type. That's a perfectly fine thing to do, but I kind of recommend against it, and I'll show you why. What if I was going to do that? Double hours, comma, rate, comma, total. That's great, and we can probably figure out what those variables mean, but what if I needed to add comments explaining what each one was? Like, what if we did this? Double height, comma, weight. Well, those aren't in the same units, right? Height and weight, they're completely different units. We don't know what units they are. I would not want to declare them on the same variable declaration, even though it's legal. I would instead do this: double weight, semicolon, and I might put whether it's in pounds or kilograms, right? And then double weight, yeah, height, and I might put whether that's in inches or, you know, centimeters or meters or whatever, right? So if you're going to be adding comments to your variables, that's a good reason to not list them all on one line. But syntax-wise, it's perfectly legal to do that. So I'll just add that as a comment. You can create multiple variables when one statement, but I recommend you do them one per line so you can add comments. What do you add comments for? To explain what the variable is. If you just have a variable named J, you didn't give it a good variable name, I'm going to have no idea what it does. So if it's not just a simple counter, you better add a comment saying what J is. Oh, J was the number of joules in my physics calculation or my chemistry experiment or whatever.
Nice. Height.
And yeah, it's giving you total fits, so you don't have to get this totally working. Just upload a note at the end of the class saying, yeah, you were here, right? Because you're not going to be able to catch up most likely. If you can, it'll be a miracle, so don't sweat it.
Why is my program not working?
Well,
Oh yeah? What's it doing?
do you think I can have a professor? Do you think
Yeah, this part is never going to print because there's no way y could equal 1.1 because y is an integer. If we wanted that to work, just come up there and change that to a double, and all of a sudden it starts working.
You forgot to.
But I'm going to leave it as an int because all my notes right about it were that. But if you want to see that message, that's what you would have to do. I'm going to go back and make it an int again. Do you want to print out now or at the end of class?
I'll just have it in the class.
Okay.
Let's see if I can catch up.
Let's
like
go.
You said.
Yeah, don't bother.
Don't bother. That's unfortunate.
But I hope you get it fixed so that would be good. So there are many different types of data. Let me give you an example of some data types. Int, and I don't know, J. Uint, K. Ooh, you gonna give me an error there? Haha, what do you know? How about byte? Oh, aren't you getting all snarky on me? Short, K.
Short.
Long, M. Long, N. Float. I'm just totally making these letters up. R. Double, S. Care, T. Bool, U. Unsigned space int.
And float's
V.
not like Float's not the float in Python.
unsigned short W. Okay, so we've seen a bunch of different data types. And then string, whatever, S equals, yeah, string S.
Char.
And,
I
yep,
did not know there
that
was
stands for
char.
character.
Oh. Bool.
So that's a Boolean variable, meaning it contains either a true or a false. That bool means true or false. A char is a single letter, a character, like single quote A, or single quote exclamation mark, or single quote anything. But it can only be one character. It's specifically a character, and that's unlike Python where you can mix up your double quotes and your single quotes with reckless abandon.
What the heck does short mean?
Good question. We have integer data types.
Oh.
Integer data types are whole numbers. There are 2-byte data types, which is a short. There are 4-byte data types, which is just the word int, or you could call it a short int. And then there are 8-byte data types. Bytes dictate how large the number can get. And a 8-byte is a long. There's one in between an int and a long, just called long, which in Microsoft's world only equals 4 bytes, and in Linux and Mac equals 8 bytes. So we're not going to use the keyword long. We will call it long, which sounds absurd. I'm going to make a long here. And in Java, they just called it long. And in every other operating system, every other compiler, except for Microsoft Visual Studio, they decided that a long was 8 bytes, and so we wouldn't be using the word long. But that's okay. So the number of bytes dictates how large the number can get. An int can get up to about 2 billion. A short can get up to about 65535. Or no, I'm going to say 32,000 because that's an unsigned short that gets that large. And an 8-byte value can get huge, ginormous. I don't know how large a number a long can get to. If we look in the PowerPoints, maybe it'll tell us. Or maybe that's for another lecture. Looking like it's for another lecture because it looks like we're almost at the end. Let's Google it up.
Thumbs down. Right?
Max value of a long. Yeah, that's big.
That is several billion.
Let's figure out how many zeros are after it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Anyways, it's a huge value.
Sounds like it's in a quadrillion.
Yeah, it's huge. It's not the largest piece of data they can hold, though. But the number of bytes dictates how large the number can be. Most of the time, we're just going to use ints because most of our numbers aren't going to go above 2 billion. Right. What is your age? 7 billion. It's not going to happen, right? So, or what is your weight in grams? Well, I'm feeling heavy today, so I weigh 89 billion grams. Probably not. Probably not. So you can just get away with using ints most of the time that you need a whole number. You never need to think, oh, I need to conserve my RAM, so I'm going to start using short values. You don't need to do that. Just use ints everywhere until proven that you need another data type. So then there are these floating point data types. Float are numbers with fractions, with decimal points. There's only 2 of those. There's a 4-byte type, which is a float, and then there's an 8-byte type, which is a double. Just use double, always, unless you have a really, really strong reason to come up with a float, and you never will. The reason I say that is because you get rounding errors. Not you get rounding errors, but when the computer starts doing floating point math, it will get rounding errors. And we could come up with a demonstration of that pretty quickly, most likely. Let's see if we can demonstrate a rounding error. I'm going to go here and declare a float. And I guess I'll call it f. And I'm going to say f equals 0.1 semicolon. And what happens if I add 0.1 to 0.9? So what if I say f equals f plus 0.9 semicolon? So f should equal 1 right now, right? Should equal 1 exactly. So let's see out less than, parentheses, f minus 1 in parentheses, less than ENDL. That should be 0, right? Thinking it through, 0.1 plus 0.9 is going to equal 1. And then so when we subtract 1 from it, it ought to print out 0. Most likely it's not going to. Ooh, look at that. Okay, fine. Put an F after that 0.1 there. And put an F after that 0.9 there. See, floats are not even the default data type for fractional numbers. They're just expecting you to use doubles. But I'm trying to demonstrate now. Okay, I knew that one. That line that says string S, I need to delete it. So if you get an error there that says redefinition, you better delete that line. I'll wander around and make sure it's working for everybody. Just because I had S declared somewhere else as well. All right, make a liar out of me. It says that it's equal to 0. Let's see if we can get it to fail though.
Oh, we're making floats now?
Well, I'm trying to demonstrate a rounding error, and I may fail at doing so. Yeah, I'm failing.
It's in syntax here, though. Multiply by 10.
You don't have to keep typing everything I'm doing while I'm trying to figure out how to demonstrate this, and if I'm not able to demonstrate it, then that's okay. All right, finally.
Just type a bunch of...
Okay, so what I did here is I created a variable called f, and I assigned it the value of 0.1. And I had to add the f suffix to it to convince it that 0.1 was a float occupying 4 bytes rather than a double occupying 8. And then I had another line here that said f plus equals 0.1 f. And I repeated that line 6 more times. So if you take 0.1 and you add 0.1, 0.1, 0.1, 0.1, 0.1, and 0.1 to it, it's going to equal 0.7. So if we take f and we subtract 0.7 from it, it should equal 0, right? Because 0.7 minus 0.7 equals 0. But when we run it, what we see is that it's equal to a very small number. That's a rounding error. A decimal point followed by 7 zeros followed by 5 is how small that number is. you know, dot 1, 2, 3, 4, 5, 6, 7, 5, 9, 6. That's what it thinks that 0.7 minus 0.7 is
I think I screwed up.
when they are floats. Yeah, you can just comment this stuff out because it's just to demonstrate floating point errors. And why is that? It's because floating point math is not exact, right? Even in our counting system, if I say 1/3, and then I need to write that down in a form that I can type into a computer, what am I going to do? I'm going to type in 0.3, and then I'm going to start adding 3's to it until I run out of space, right? There's a limit. And so I'm never going to be able to represent 1/3 precisely in base 10. Well, similarly, I cannot represent 1/10 in base 2. It won't go precise. 1/2 goes into base 10 just fine, and base 2 just fine, and 1/4 and 1/8, but 1/10 does not go into binary cleanly. It's some irrational number like that that goes on forever. And so when we started adding 0.1 to 0.1 to 0.1 to 0.1, we got some rounding errors. Because if I took this right here, what if my numeric scheme only allowed me to carry things out to 4 decimal places? And then I said that plus that plus that. When I added it up, that would not equal 1, like 1/3 plus 1/3 plus 1/30. Instead, it would equal 0.9999. Right, and so if I said 1 minus that, I would get a very, very, very small number. That was the rounding error. And the limit is how many digits we can carry. Well, a double carries twice as many digits as a normal float. It's really a lot more than this. But anyways, you know, when I did that subtraction, the rounding error would now be a lot smaller. Now, since doubles are 8 bytes wide, they can hold extremely large, extremely precise values, and the rounding errors will be very small. So we're just going to use doubles rather than floats all the time. Why increase the rounding errors by using the lesser data type?
I have a question.
Uh-huh.
Okay, so my identifier, it's undefined. How do I define the float dev?
Got to give it a data type in front of it. Well, that's one. Compile it. If you try to rebuild it, that error may go away. So choose a build, rebuild solution.
I was thinking it should be defined.
Double click on it again.
I'm going to start talking about headers. Probably not for a while.
You got me bogged.
All the headers from web development, but I think it's a different header.
All of a sudden everyone just be like, well, time to go to sleep.
You got me. Oh, it's because of something way up here.
Oh, good. Oh, yeah, you put it in second brackets to it.
Yeah, okay, so now if we take off the ones, it'll look just as well. Yes, sir.
Use minute 46 and 46 errors.
Oh, you put
Yeah, I think it's doing the
brackets.
same thing was, scroll back down. Let's find out the error of this. Double click on the first one.
I'm telling you, I'm going to buy Dell from now on.
All of this stuff was added after the system pause, semicolon. So it's after the end of the program. So grab those 2 lines and move them down to the very bottom. Let's undo the change we just made and then cut them. Cut those 2 lines and paste them at the very bottom. Oh, okay. This is starting to look very strange. All of our code needed to be between the curly braces and the may. Okay. I'd like for these to be
tabbed correctly, so we're going to highlight, and we're going to go up to Edit, Advanced, Format Document. Then we've got a couple of things here, put a semicolon there. Get rid of that one. Right. Getting our number of errors down.
Oh, yeah, that's right.
Let's try rebuilding and see if any of them go away. Go to Build, Rebuild Solution.
So anytime you use a new function, make sure to put that
Double click that one. This one was my fault. Just comment that out. Delete it. That'll work. Go ahead and build it one more time. Yeah, just like that. Good. Sure. All right, go ahead and run it. Sure. Anybody else? Working okay?
That's good.
So input, processing, and output. Generally, we gather input. It can come from different places, the keyboard or from files. We process the input data, and then we display the results. You can send it to a screen, you can write it to a file, or you can do something more esoteric like control a speaker or something. The programming process. I love this line. Visualize the program running on the computer. This sounds so very meditative, so very zen. I'm going to visualize the program running on the computer. Okay, anyways. So the programming process is to get your requirements, define what the program is going to do. And it talks about using hierarchy chart, flow charts, and pseudocode. Well, this isn't fundamentals of programming, so I'm not going to ask you to do flow charts or hierarchy charts or pseudocode. But pseudocode is useful for creating algorithms. And if you ever cannot figure out the algorithm for solving your problem, like if I say calculate the area of a sphere and you can't figure it out, just ask me for help, and I can text you the algorithm for it. Well, it doesn't mean I'll write the code for you, but I'll give you the pseudocode for it. Check the model for logical errors. You type the code, you save it, you compile it, you correct the errors found during compilation, just like Lucine and I were doing, right? Because you notice it said there were 46 errors and we only had to make 3 changes. Right, so it's going to show an absurd number of errors. And then you fix one thing, you fix the other, and you fix the other, and they're all fixed. Okay, what I want to do now is let's go and look. I believe there should be a quiz out there available for us to look at. Let's see if that's the case. If I go to assignments and I look at the quizzes, just one called Chapter 2 Review. Let's do this one together. The only reason I want to do it together is so that I know that we know how to do the quizzes from now on. So I'm going to, first I need to switch to student mode, forgive me, but you can click right into it.
Oh, it's assignments. Attempts unlimited.
Yep, it says unlimited attempts because if you don't make a great grade on it, you can keep retaking it until you get as high a grade as you want. Now, if there are any fill in the blanks or anything like that, when you submit it, it will probably count some things wrong that are not wrong. Don't worry, it just means that I need to go and grade it by hand. So I'm going to click on Quiz Chapter 2, take the quiz. Open book quiz. You can use your book, your notes, the PowerPoints, or search Google for help. I don't want you searching Google during an exam, but for a quiz, why not? However, don't use Visual Studio or Xcode or something to figure out the answers. Do the quiz yourself. Don't ask for help from anyone else. You can text me for help, or you can ask me since we're doing it together. Click true if you agree. Well, I agree. Which of the following are legal variable names? More than one is correct, but some of them are wrong. Can anybody, are yours in a different order than on mine? Are they randomly ordered, or does it start with the one with the space and end with the one with no space?
Randomly ordered.
Okay. Well, anyways. How's about this one? Is that a good not a good variable name, but is that a legal variable name, tax rate?
Yes.
Yeah, nothing wrong with that one. How about this one, 2016 tax rate?
No.
No.
Right.
Can't start with numbers.
Can't start with numbers. So that one's good, but that one's not. It can end in numbers just fine, so that's fine. But they can't have percent signs in them, so that's not right.
That one's underscore.
Underscores are great, but
And
spaces are not.
You cannot have a space.
Right, because it makes it two variable names. Alrighty. Just from today's lecture, how many operands does a binary operator require?
None of the above. I'm just kidding.
Yeah, none of the above.
I'm just messing with you.
These should, the fact that it's not randomly ordered means that none of the above is actually technically a true answer on my screen, because it's not 3 or 1. But we know what the answer is. It's 2.
I was only back messing with you.
Yeah. I need to modify the quiz so that not all of these are randomly ordered. Assuming you have the following declaration. Int a equals 0, b equals 0, z is equal to 0. Write a statement that does the following. Store 10 into c. Well, the variable name then is going to be c. And we want to store something into it, so we're going to assign it a value with the assignment operator. What are we assigning into it? 10. And
C equals 10.
don't forget the semicolon. So there we go. Now that's a fill in the blank, right? And so when you submit it, it may get marked wrong. Don't get bummed out. It just means that I have to go and grade all the quizzes by hand.
Isn't it equal sign between C and 10?
Yeah, there is an equal sign there between the C and the 10.
Okay.
Yep.
Because I can't really see it very well.
Yeah. And I love that when I zoom in, it makes this purple stuff cover half the screen, but, well.
See, on int, C equals 10.
It was already declared.
Oh, gotcha.
I wouldn't count it.
Never mind.
I would not count it wrong if you did that, right?
It already says int, because you can put multiple variables in.
Right, but it is already declared, so we did not have to put int there.
Never mind.
No, perfectly good question. That's the kind of thing that it would count wrong, and then I would go back and give you credit for. Okay, so here's another one. Store the value of a plus 10 into b. Well, into b tell us what variable it's going to be stored into. B equals. And what are we storing into it? A plus 10, semicolon. All right, one more. I don't know why I chose C all the time. Oh, I guess we did B there. But anyways, we're back to using C. So C equals what?
3.14 times B times B.
Yep, exactly. 3.14 times B, or if you wanted to get real clever and use the POW function to take B to the power of 2, I wouldn't count you wrong, but it doesn't ask for anything that complicated, so just do that.
K.
All right, since K is a character and not a string, we have to use the apostrophes. We have to use the single quotes. They're not interchangeable like they are in Python. So C equals single quote uppercase K. And if you made it lowercase k and it counted it wrong, I'd go back and give you credit. There's more than one way to do this one. There's 3 correct answers. Assuming you have the following declaration, b equals 100, write an assignment statement that does the following. Subtract 1 from b and store the result in b. 3 ways to do it. Here's the first way. And you don't have to put all 3 ways, just pick which way you like. b equals b minus 1 semicolon. That works, right? Take 1 from b and store it back into b. That's totally good.
That's the simplest way.
Or you can do like you did in Python, b minus equals 1 semicolon. That works. or the shortest one is b minus minus. So any of those will work. B equals b minus 1, or b minus equals 1, or b minus minus. All three of those will work. Just pick one. I list all three here because I just want you to know that there's three different ways. That would be the most preferred, though. That's the way that professional programmers would do it.
Which way?
B minus minus. All right, if we want to go to the next line, are we going to use /n or ENDL, or will they both work?
They would both work.
And they both work. And just because I'm giving you all the answers this time, or we're agreeing on them together, doesn't mean that you can't take this quiz again. When it's getting closer to exam time, you're going to want to take through it again just to refamiliarize yourself with it, right? Even though you've already done it and gotten it right, there's nothing wrong with looking at it again. All right, here's one that if I ask on an exam, some people will get wrong. Write a line of code that will print, "My name is Bob Roberts." All right, the one that displeases me the most is if somebody does this. "See out, my name is Bob Roberts." Okay, no. Why is that not right? Because I said using the following variable declarations. So we're going to use these variables. So we're going to see out, and it does need to say, "My name is Bob Roberts." So that'll be the first part of our output. My name is, space, end quote, and here's what people will do wrong. F name followed by L name. And what's wrong with that? It'll print out "My name is Bob Roberts," but there's going to be something wrong with it. Well, here, I'll show you.
It's not going to space it out.
It isn't right, no space. It's going to say, "My name is Bob Roberts." So instead, we're going to put after F name, we're going to put arrow, arrow, quote, space, quote, arrow, arrow. Now we have that space. And there should be a semicolon at the end. Alrighty, how do we make a comment? A single line comment. Yeah, go on. Yep. 2 slashes, 2 forward slashes. And what symbol begins preprocessor directives, like the include statements? Yep, the hash. Somebody came up with the world's silliest term for that, which is, it's the octothorpe. Believe it or not, somebody decided that the hash symbol was called octothorpe. You can find it in AT&T manuals from the 50s. Yes, sir.
What is, for question 11 again, I got slightly behind.
All right, how do you make a comment in our code? We've been using the double slashes.
All right.
That's it. Yep.
And then put a hash, number 12.
All right, we haven't talked much about modulus. I'm not sure why we didn't talk much about it. The quiz is asking about it and we didn't talk about it. What's modulus mean? Well, we remember from fundamentals that it means remainder. If we do this, see out 5 modulus 4. 4 goes into 5 one time with a remainder of, well, 4 went in 1, 5 minus 4 is 1. So the remainder of 5 modulus 4 is 1. That would print out 1. How about 6 modulus 4? Yeah, it's 2. 4 goes into 6 one time with 2 left over. 7 modulus 4. 4 goes into 7 one time with a remainder. How many is left over? And y'all know what I mean by leftover, right? If you were doing hand division, and I had that 7 there and that 4 there. 4 goes into 7 one time with a remainder of 3. That's all the percent sign means is remainder. So what about 8 modulus 4? What's that one?
Oh, there's no modulus here that goes into it.
It goes in there cleanly, right?
Yeah.
There's no remainder, so it's 0. Yep.
So how does it write what the modulus is? Like, you know what I'm saying? Like, what's the output?
Wait a minute, is our class supposed to be?
If we type this in, it would actually just print 1.
Okay.
Yeah, it would just display it.
There's no symbol beforehand.
Right, there's no weird ampersands or hexadecimals or anything. We could prove that. Let's go back to our code and tack that on. Cout less than 7 modulus 4 less than ENDL. That's going to print out 3.
So at no time it wouldn't say 1.3.
Right, the modulus has to, in this language, be a whole number. Some programming languages support modulus of fractional numbers. You could say 7 modulus 2.5. But
Which is like the exact answer.
right, but this modulus is integer math in this language. That's an incredibly good question. Back to the quiz. Where'd my quiz go? I didn't close it yet. Oh, there it goes. All right, so percent sign means modulus. And what will this print? And here's what I mean by don't open Visual Studio. So we're going to print out x. X is equal to a plus b. Well, a is 5, and you've already got the answer. And b is 3. So 5 plus 3 is 8.
Oh.
Something tells me that it's going to ask for y next. So what is y? And it's a trick question. It's not a trick question, but remember, whole numbers only. Since a and b are whole numbers, the answer is going to be whole numbers, so it's going to be rounded down. So a divided by b, 5 divided by 3 is like 1.6 or something like that, but it's going to be a whole number because they're both ints, so it's just 1. You got it.
It's either 1 or 2.
Got to be 1 because it truncates, meaning it drops everything after the decimal.
Can you run through that again for me?
Absolutely. Since a and b are whole numbers,
Okay.
when it does the division, the answer, the result is also a whole number. So it can't be part way because it's a whole number.
Asking for.
So like if you have 3 divided by 4, it doesn't equal 0.75. It just equals 0.
So it's asking for x, and the integer x is a plus b equals.
It's because both a and b are whole numbers, and so when they're divided, the answer is the result is a whole number as well.
Because you didn't define it as a floating function.
Yeah, if we defined a and b as doubles, then it would be 1.6. But it doesn't really matter that int is declared as an x or whether, although that's a good point, it's being stored into an int, so it has to round it down no matter what. But even if that said double x is equal to a plus b, this part of it gets done first before it gets copied across the equal sign. And a is an integer and b is an integer. So a divided by b also has to be an integer, meaning it has to be a whole number, meaning that it's anything after the decimal point is dropped off.
Even with the double, it's still going.
Yep, because it all happens before it gets copied across the equal sign. It gets its final answer and then pushes it across the equal sign. That makes sense?
Yeah.
Because it doesn't look ahead and go, oh, you know what, I guess I could have made it a double after all. Instead, it figures it out and then it moves it across.
So like the int is basically trying it cuts the front line for the double.
Yep. So like if we did this, int value equals 1.6. It's an int. It can't equal 1.6. So what's it going to equal? 1. Exactly. And so if it says int value is equal to 3 over 2? Well, it can't be 1.5. All it can be is, what is 3 divided by 2 rounded down? Well, that's not going to work because I've already declared the variable. Okay, but anyways, there we go, right? What is 3 divided by 2? Normally it's equal to, come on guys, we don't want to be here all night. Tell me, 3 divided by 2 is
1.5.
1.5, which rounded down because these are ends, makes it 1. What if you had 1 over 2? That's 0.5, but since these are ends, it rounds down. And what's 0.5 rounded down? 0. So if we print out the value at this point, it's going to print out 0. Then adding our comments here, it's actually time to go, but that's a 1 there because it got rounded down to fit into an end. And this is a 0 there because, again, it was rounded down. So that's why when we're printing out the value of y, a divided by b, 5 divided by 3, but going into an end, these are integers. 5 divided by 3 is 1.6, but it rounds down to a 1. Okay, and what is z? We've already talked about modulus. What is 5 modulus 3? 2, right? 3 goes into 5 one time with the remainder of 2. Now, I don't even remember talking about that in this chapter, did we? Let's go look. No, we didn't. So why is it in the quiz? All right, well, we're going to tell you anyways. If you want to make a variable a constant, you use const. A constant is a variable that cannot be changed once it is assigned. Like this. If I say const int value equals 1.6, then when I try to change it, when I try to give it a new value, it's a syntax error because it has been marked as a constant. Can't change. Once given a value, it can never be given any other value. So that's what const means. And I don't know why it's in my quiz if it's not in the book. I mean, if it's not in the PowerPoint. But that's the key word that marks a variable as a constant. In Java, by the way, it's the word final. In Python, it's, well, there is no const in final in Python. All right, if you want to calculate whole numbers,
Integer.
it's a good form. You don't want doubles. You don't want floats. Bools mean trues and false. Strings are for words. All right, how about a series of characters like somebody's name?
String.
Yep. How about a nice, good old floating point number?
Double.
We want to use double. And so if it's true or false, it has to, well, one of the above. Bool. Boolean. Okay, we haven't talked about the ternary operator yet, so there's no way you could possibly answer this question. Why do we have these questions there? I need to remove them. There's one more operator called the ternary operator. It's the question mark, and I'm sorry I'm keeping us here after hours. I should just give you the answers and let us know. But here's what this does. If you do this, x is equal to 3 greater than 2, question mark, 9999:888. That looks like gobbledygook. But here's what it really means. If x is greater than 2, x equals 999, or excuse me, if 3 is greater than 2, x is equal to 999, else x is equal to 888. It's a very short way of writing this. This gets evaluated. This is the if part. The assignment is the thing after the question mark, and the else is the thing after the colon. So is 3 greater than 2? Somebody say yeah.
Yeah.
Yeah. All right. So 3 is greater than 2, so 999 would get copied into X. What if it looked like this? Is 1 greater than 2? 1 is not greater than 2, so 999 doesn't get copied into X. 888 gets copied into X. So if we go back here and look again, X is 0. Please enter a value into X, and then Y equals X less than 0, question mark. So this is the if part. The user enters a 10. Is 10 less than 0?
No.
No. So is it going to equal to -1? No, it's going to equal the second part, the 1. And it's okay if you don't totally get that because it's not in the book. All right, so what can store a larger number, an int or a float? Floating point numbers are always larger than any integer kind. Why? Because they support exponents. You know, even if you only have 4 digits, right? If you have 9999 or you have 9 to the power of 999, which one's larger? The float. Always, 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 floating point data types can hold larger values than ints. So, which one is limited to about 2 billion or less? If we go and look at my notes, and I've already heard the correct answer a couple times from y'all. Oh, did I put them actually in the code itself? Yes, I did. Ints can hold up to 2 billion. They're about a little bit more than 2 billion. Whereas shorts hold up to 32,000 and longs hold giant values. So, an int is the one that's limited to 2 billion or less.
And then
If you want to hold a floating point number, a large one, float is the less accurate floating point type. What's the more accurate one? We've been using them. We're going to use doubles consistently. We're never going to use floats if we can get away with using doubles.
Stupid question, what's the E plus? The 1 E plus?
Exponent.
What about- I was just
Yeah,
wondering.
like 1 times 10 to the power of 37.
So that's 1 to the power of 37.
Yep, 1 times 10 to the power of 37.
Could you go back to question 10?
That one?
10.
Oh, sorry.
I guess we're finished now, aren't we?
Well, let's look. We're going to click the submit button. I need to make a Dropbox so we can submit our stuff. Submit your quiz.
Oh, wait, I gotta submit my lecture.
Yeah.
And
So we're not going to do all the quizzes like that, but I figured the first run through, why not? But I recommend that you take them again, right, on your own. And let's not do any homework this time. We'll give our homework assignment on Thursday.
You said no homework assignment?
Yeah.
That's very generous. Man, you're feeling really generous now. You did our quiz with us, no homework assignment?
Yeah, I'm being too nice.
And we only have 5 people show up. Man, you're here for tonight.
All right, you changed my mind. We're getting homework. No, I'm kidding. I'm kidding.
Alright,
All right, and there we go. There we go. There's the Dropbox for now, so just click assignments and you'll get to it.
fresh.